Hello class, we're going to go over sample exercise 5.1 from this worksheet. From the this is from the assignments under thermochemistry notes. I have a sample exercise problems and review problems. These will be where I get most of the quiz questions from, as well as the PowerPoint. So you kind of want to go through this on your own. The way this works is I'll have a description and a solution and how to analyze it, and then I'll have a couple of practice exercises. These are probably useful to do on your own. I will probably not go through them at all, but I will go through this and kind of clean up this part a little bit. So yeah, let's get started. First, we're going to read the question and figure out what we know and what we don't know. So what's given? Well, we're given a mass here, 5.4 kilograms, at a height of 1.6 meters. That's excellent. So what is that telling us? Well, if I draw a quick little picture here, what that's telling us is, starting at point 0, I have this bowling ball, right? Terrible bowling ball. The 3 holes or something. Yeah, I don't know. I have this bowling ball, and as it rises 1.6 meters. Now, I don't know about you, but if I had to pick up a bowling ball, it's going to take a little bit of work. I'm going to have to move something over an amount of distance. That distance is 1.6 meters. As it moves upwards, it's going to take work. Why? Well, the opposite of the work. Well, there's some gravity pulling it down, and I have to pull it up against the gravity. Cool. So here is what we've been referring to as distance. It can also be referred to as height. Awesome. So let's scroll down here. Good spot. Let's see here. So number 1, we have a mass of 5.4 kilograms. It was raised to a height of 1.6 meters. Excellent. When the potential energy at 1.6 meters. Well, that's interesting. The potential energy tells us that when it's potential, it's not moving. If it's moving, it's kinetic energy. So as we rise it up and hold it there above the ground 1.6 meters, it's not moving yet, telling us it's potential energy. Well, what is energy? Well, we know energy has 2 forms, heat and work. Now, there's no heat in this scenario. That's cool. So what is the work or the energy that it takes to lift the bowling ball? We have an equation for that, force times distance. Or in this case, the distance is force times height of 1.6 meters. So what's the force then? Well, the force is equal to mass times acceleration. Acceleration on planet Earth is due to gravity. Therefore, it has a constant number. The constant number is 9.8 meters per second squared. That's a really important constant. You should memorize that. Okay, cool. So that tells us a lot. That tells us that it takes force to raise and work to raise a bowling ball 1.6 meters. The mass, 5.4, times the acceleration, 9.8. Excellent. And what are my units here? Well, on the side, I'm going to do my units in maybe a different color, like purple. I have kilograms times meters per second squared. I like to do my units away from the problem. That way it doesn't bundle up the math. So, FYI. So what's 5.4 times 9.8? 5.4 times 9.8 is equal to 52.92. Excellent. So we have the force now. And what is the force units? Well, they're going to be in kilogram meters over second squared, which happens, not by coincidence, to be equal to a Newton. Now, what is the work? What is the work that it takes? Well, the difference between work and force is very simple. It's distance. So force times the height equals work. Well, the force was 52.92 kilogram meters over second squared times the height. The height is 1.6 meters. So my units, if I multiply those two together, are going to turn out to be kilograms times meters squared over seconds squared. So if we look over here, what's the difference between this and this? Difference between force and energy is distance. Something to remember. Hint, hint, for, let's say, the quiz on next Thursday. If you want to remember that for the quiz, that might be useful. Cool. So what's the work? Let's calculate the work. Work is equal 52.92 times 1.6. This thing's terrible. Fifty-two point nine two, 84.672. All right. And 67 kilogram meters squared over second squared. Excellent. So that's the amount of work that has been done on the object to lift it up, which happens to be equal to the potential energy. So as the potential energy reaches a maximum amount of 84.67, and potential energy means that it's moving, as kinetic energy means that it's, or potential energy means that it's not moving, kinetic energy means that it's moving. At this point, my bowling ball isn't moving. I'm just holding it above the ground. It's all potential energy. Once I drop the ball, it starts to move closer to the ground because of gravity. All that potential energy gets transferred into kinetic energy. So how do we relate work with energy? Well, it's the same thing. How do we create, and the question that we're going to ask here for B is, what is the velocity? Now, let me do that better. What is the velocity of the falling object? Well, how do we know how to relate work to energy? How do we relate work or energy to velocity? Well, we have an equation for kinetic energy is equal to 1/2 mass times velocity squared. And I know that work is the same as energy, so how can let's sub work in for energy, and then we'll calculate for velocity. All right, so W is equal to 1/2 mv squared. Multiply each side by 2. 2W is equal to mv squared. Divide by m on both sides. That'll cancel. V squared is equal to 2W divided by m. Square root both sides to cancel out the square. And I'm left with a really fancy equation. Velocity equals 2W over m squared root. Excellent. So what is the answer, or what is, if we calculate this, the work, 84.67 divided by the mass, 5.4 times 2, all under a square root. So let's see here. Get out of here. 5.56. Velocity is equal to 5.56 or 5.6. And what are my units here? Well, over here I have work divided by mass. So my units for work are going to be, let me back up here. Change colors. So for the units, I'm going to do the square root of my work, which is kilograms times meters squared over seconds squared, divided by the kilograms over 1. So this is what I'm doing here. Now if I flip this over and inverse it, it'll be 1 over a kilogram, which allows my kilograms to cancel. The square root will cancel the squares, and I'll be left with meters per second, which is good because my velocity is measured in distance over time, meters per second. Cool, so that's our problem. Excellent. So just to do a quick review, what we did is we calculated the amount of force using gravity of a 5.4 kilogram object. It has that much inherent force. I lifted it up a height. It took about a little bit of work to do that. It took 84.67 kilograms, joules, I'm sorry, I never added that in here. This is equal to a joule. 84.67 joules to lift this thing up. And that's good because the difference between force and energy, which in this case is work, is distance. Now, the next question was to find the velocity of the falling object. To find the velocity, we know that work is the same as energy, so we subbed in 84.67 and then solved for v in our kinetic energy equation. Doing a little bit of algebra, we end up with 5.56 meters per second squared, about. Excellent. Tomorrow, you should definitely work on these practice exercises. You should definitely work on those. More or less, one of these two will be on the quiz. If you have questions, see me after school or at lunch. Otherwise, you can, if you finish those two questions, you can work on these ones. Have a great day, guys.